I thought before we did too much more of a teardown on this engine, we would start looking at some of the parts just briefly on what they are, what their functions are, how they interact with each other. I thought we'd start with the blower housing. The blower housing does so much. It has so many different functions. The first thing is it has, again, the stamp numbers on the front so that we can specifically for this engine get replacement gaskets or replacement any parts for it that we may need at a future time. Another thing that it does is it tells us where in the manual to find our torque specifications for tightening down the different bolts. It also has our starter motor in it. If you'll notice, these pawls that are pulled out, okay, they fit on a cup on the flywheel. They go in here. So as you pull it and the pawls come out, it's going to turn this flywheel for us. Another thing the blower housing does is it has a unique shape. And working in conjunction with our flywheel and these fins, it's going to be blowing air around our cooling fins. It's going to be blowing air around our cooling fins on the cylinder and the head, dissipating the heat so that it doesn't overheat. That's why it's crucial that you never run one of these small engines without the blower housing on it, or you'll destroy the engine quickly. Okay. Another thing that the blower housing does with the flywheel is it operates our weather vane here. And that's done with this weather vane right here. As this flywheel spins, it creates more wind, which pushes this weather vane back. Okay? And then the springs will bring it back as this slows down. So again, with the blower housing and the flywheel and the governor's vane, it all works together. This is for controlling the constant speed of the engine. It works in conjunction with our governor spring and our idle spring. And we're going to get more into this, but this weather vane goes straight to the throttle, which will control, again, the speed of the engine. Now, a lot of people don't understand that the governor isn't designed to keep the engine from over-revving. It's to maintain a constant speed. For example, when you're mowing and you hit high grass, you want that engine to be turning at the same speed as if it were cutting just normal, regular height grass. You'll also notice that our flywheel is made of aluminum. On a lawn tractor, it would be made of cast iron. And what I'm getting at is we're talking about mass now. We have a piston that's going up and down, and we have to maintain that piston momentum. And the aluminum flywheel isn't heavy enough to do that. So most people don't realize that our flywheel and our lawnmower blade are actually part of the flywheel. That's why you should never run one of these small engines without the lawnmower blade on it, because it's actually part of our flywheel. These fins are very carefully designed. You'll notice that they're not the same height, and there's different shapes to them. When these things were spinning, they were getting a whistling sound, and the engineers came up with changing the shapes, and that would change the harmonics of it, so it didn't get really loud. Very clever. Inside the flywheel are magnets. And as the flywheel spins, it's going to be coming in front of a coil. And as the magnets pass in front of the coil, it's going to build up a magnetic field. And as it goes past the coil, it's going to collapse that magnetic field and send a charge to our spark plug. That's how we get our ignition. We also have, that's one type of timing, an electric timing. We also have a mechanical timing that's maintained with this cutout right here and the flywheel key. Okay. You're going to learn more about that later on, but that's going to maintain our mechanical timing. That's when the optimal time for the fuel to be ignited. Okay, that's where the piston's at the right place, the valves are at the right place, and the electronic timing when the spark should occur at the right time. And that's maintained with this key. So let's real quick, so that we don't get ahead of ourselves, just show the overview of the parts. There are three main castings: the crankcase, the sump cover, and the head. Then we have a crankshaft, a flywheel, and a piston. Of course, we have the muffler. We have two seals that ride on either end of the crankshaft. They, of course, go in the crankcase casting right here, and the sump cover right here. Then we have a gear that fits on our crankshaft. Like so. And that turns our camshaft. The camshaft, as it spins, is going to be lifting up our valve lifters, just like that on these lobes. And as they do that, they'll be compressing and releasing these springs, opening our valves. We also have an oil slinger, and I hooked some air so that you can see exactly how well this thing works. Can you imagine that? Inside the engine, throwing all the oil into the little orifices that we need. Very effective. Then we have our crankcase breather valve that we discussed yesterday. And of course our piston with our connecting rod. Pretty amazing. Well, this is a 3D representation of our engine that we just took apart. We have the flywheel and the lawnmower blade, again, for the mast to keep this thing going. We have a crankshaft with our piston and our connecting rod. We have a gear here that is half the radius of this gear. This is our camshaft gear, and this is our oil slinger. And the camshaft moves our two tappets, okay, that push up and down our valves right here, allowing fuel into the head and exhaust out of the head. And this is our head with our spark plug. And I know it's very basic, but this is pretty much the internal workings of that engine. There's two types of engines out there that we're going to be dealing with in small engine repair. One is a two-cycle engine, or a two-stroke engine. And it's the type that you find on chainsaws and weed eaters. It's the kind that you mix oil and gas together. We're going to deal with that at a later date. Right now we're going to be dealing with lawnmowers, power generators, log splitters, those kind of engines where you actually add oil to the crankcase. Okay? That's called a four-stroke engine, and that's what we're going to delve into now. I've removed a lot of the bolts already so we can get right into the engine. The first thing we're going to remove is the blower housing. Then we're going to remove the spark plug cable and just kind of toss it aside. And I've already removed most of the head bolts. I just have that one last one, and the head will come off. There's two types of four-stroke engines dealing with the valves. There's the one called a flathead, and the valves are on the side of the piston. And the head is narrow, it's flat, if you will. The second type is what they call an overhead valve, where these valves are then placed directly in the head and they're over the cylinder. We'll be dealing with that at a later time, but the reason why I want to use a flathead for you is it's easier to illustrate the different machine cycles, or what we refer to as the four-stroke engine. If you understand how a small engine operates, what's required, what it's doing, when it's doing it, it'll be a lot easier for you to diagnose what's wrong and troubleshoot and then repair that area that went wrong. So let's get into this. The first part of a four-stroke engine is what we call the intake stroke. Now, a stroke is the full travel of the piston in the cylinder from top dead center, where we're at right now, to bottom dead center. Now, it doesn't matter if we're coming up or going down. That's considered a stroke. So again, the first one is going to be an intake stroke. Before we get even into that, look, there's two valves right here. One's a little bit larger than the other one. And the top one, if you'll notice, from the carburetor there's a tube and it enters right there. A valve is like a door, if you will. And as you turn the flywheel, the door will open, or the valve will open. Okay? And in this particular case, it's the intake valve, and it lets in the air-fuel mixture that's going to go into this cylinder right here and eventually explode. The bottom one is our exhaust valve. See, it just opened right there? And if I remove our muffler, and shine the light into our muffler port, you should be able to see light coming out of this valve. That's for the exhaust to come out of the engine through the muffler. Now, a piston has piston rings, and what that allows is a tight seal between the cylinder walls and the piston. So when the piston travels downward, it actually will create a vacuum. And with the intake valve open, it's going to draw in air and fuel mixture and bring it into the cylinder through this valve or this doorway. This is called the intake stroke, by the way, the very first one. Now, if you're wondering, how do we get the air-fuel mixture into the cylinder, or when the exhaust valve is open, how do we get the exhaust fumes out of the cylinder? That's accomplished by the head. Can you see how it's recessed out right here? That's to fit the two valves, and it's recessed right into where the cylinder will be, so the gases can flow in or flow out easily. Notice also that there's electrodes sticking right through here. That is your spark plug. When the timing is set just right, at the right time, a spark will emit and cause the explosion. So, back to our first stroke, our intake stroke. The piston is moving down, creating this vacuum, drawing in air-fuel mixture, and it's pulling it into the cylinder. When we hit the bottom, what they call bottom dead center, the intake valve closes, and the piston starts to travel back upward. Notice both valves are closed. This is called our compression stroke. They've found that if you compress air and fuel, it explodes better. So right about here, before we hit the very top, right about there, the spark plug is going to emit a spark and an explosion is going to create. With the momentum of the flywheel and the lawnmower blade, it's going to carry it over the top. And this is now starting our power stroke. As the fumes expand and burn off, it's going to force powerfully this piston back down this cylinder, just like that. All right? That's our power stroke. And when we hit bottom dead center again, notice what happens. Our exhaust valve opens, and our piston's going to start coming back up and forcing those spent fumes out this doorway, through this port, out the muffler. That is called a four-stroke engine. What do you think is going to happen next? That's right. The intake valve is going to open up again, and the series is going to continue on. Well, let's put this new knowledge to some practical use. Let's create a hypothetical situation where you went through Craigslist and you found a rototiller that you were interested in, or a riding lawnmower, and you wanted to see how much life is still in that engine. Well, we could use an advanced diagnostic tool. Very simple, but pretend now that I have the head gasket on and the head bolted to the engine. We're at the top dead center of a compression stroke. Both valves are closed tightly. We would remove our spark plug and put compressed air into that port. Then what we would do is we'd come down to the engine and we would listen next to the muffler. And if we heard a hissing sound coming out of the muffler, what would that indicate? That's right. That would indicate a valve that's not seating properly, or it might be burned, or it might have a crack in it. And air is whipping by it and not giving us a good compression. If you have weak compression, your engine won't run, or it won't be strong, or it'll bog down easily. Say we heard hissing sound coming out of the carburetor. Well, we would know that that would be our intake valve that's not seating properly. Maybe the valves need adjusting. If you open up your dipstick and you hear deep in the engine a hissing sound, that would indicate that air is passing by the piston rings. What that could mean, a piece of carbon that was built up on your piston and it might have broke off and scratched or deeply scored your cylinder, and air is whipping past it. Or it could mean that this engine had heavy use and the piston rings have worn down. Say we heard hissing sound coming out of the head of the engine, right? That could indicate that we had a blowout of our head gasket somewhere, maybe between here. And the head gasket might just need replacing. All right, just some thought. I'll catch you on the next one. Where I'm getting the information for the little mini-series that we're doing on the L-head Briggs & Stratton engine teardown. I've been watching a lot of these repair videos on YouTube, and I find them fascinating. And so I decided to invest a little time and money into this and do a practical kind of home study course on it. And what I found out was Briggs & Stratton has a course for their Master Service Technician. Well, I'm not going for a Master Service Technician certification, but I thought it would be interesting to share with you as I run through it some of the things that I'm learning from their course studies. I purchased their the textbook that we'll be getting a lot of our information out of. It also came with a workbook with a bunch of questions and an answer key. It also came with a CD that has questions, videos, and flashcards to help with their examination. And they wanted us to have 2 repair books that we knew quite well. They're going to be an open book exam. This is the L-head, and then they wanted us to also have the opposed twin-cylinder repair manual. And we might even get one of those engines and tear that down together also. and get a much better understanding as we're going through it. But the information in this textbook really blows me away at how in depth, and it covers more of the whys than hows. Everybody wants to know how it works and the function, but they go into even more depth. Clearances, why they're like that, why are the angles cut the way they are. Just very fascinating. All the different ports on a carburetor, what they're there for, what they do. I want to tell you some of the facts that I found out about this. The small outdoor power equipment industry is huge. It's $8.5 billion a year. And it provides 33,000 service technician jobs. So if this does interest you, there's more small engines out in the environment than there are cars. Look in your garage. You've got pressure washers, generators, lawnmowers, riding mowers, edgers, weed eaters, chainsaws. I mean, small engines are out there, and over time they are all going to need repairing. This is a few years back, but Briggs & Stratton made 8 million engines a year just to keep up with the new power equipment that was coming out on the market. Back to that service exam, if you're interested in it, it's 311 questions, and it takes 4.5 hours. All right, I just wanted you to see where we're getting our information from and the course actually that we're trying to follow here. Pretty interesting. I'll catch you on the next.